The diagram shows a cuboid of length 5 centimeters, width 3 centimeters, and height 7 centimeters. Each measurement is correct to the nearest centimeters. Calculate the minimum possible volume of the cuboid. Now, in general, the volume of a cuboid is going to be equal to, right? It's going to be equal to length, right? The length multiplied by the width, right? Multiplied by the height, okay? But here they want the minimum possible value, sorry, the minimum possible volume of this cuboid. And so in order for us to figure out the minimum possible volume of this cuboid, we're not going to be using, even though the formula is length times width times height, we're not going to be using, let me show you, we're not going to be using this length, right? And we're not going to be using this width, and we're not going to be using this height. We're going to be using, first we have to figure what is the L minimum. We're going to be using L min, right? So the lowest that the length could be, right? And we're going to have L, the width minimum, right? Because they want the minimum possible volume. So we're going to use the lowest width that W could be. And we're going to have H minimum, which means the smallest H could be, all right? And so the first thing we have to figure out is what is L min, W min, and H min? Like what is the lowest length we could have? What is the lowest width we could have? And what is the lowest height we could have, all right? Now, in order to do this, we're going to subtract. So the minimum possible volume is going to be the lowest possible length multiplied by the lowest possible width multiplied by the lowest possible height. And in order for us to determine that, we have to subtract, all right? We're going to subtract by 0.5, and the reason is because, notice that they said correct to the nearest, they said that each measurement is given correct to the nearest centimeters. And so in order for us to find the L min and the width min and the H min, we're gonna, in each case, subtract each of those values by 0.5 centimeters. And so we have 5 centimeters minus 0.5, which gives us 4.5 centimeters. We have 3 centimeters we have 3 centimeters minus 0.5 centimeters, and that gives us 2.5 centimeters. And we have 7 centimeters minus 0.5 centimeters, and that gives us 6.5 centimeters. Again, we have 5 centimeters minus 0.5 centimeters, and that gives us 4.5 centimeters. We have 3 centimeters minus 0.5 centimeters, and that gives us 2.5 centimeters. And we have 7 centimeters minus 0.5 centimeters, and that gives us 6.5 centimeters. And so when we multiply, we get 4.5 times 2.5 times 6.5, and when we multiply, we get 73.125 centimeters cubed. So the minimum possible volume of the cuboid is 73.125 centimeters cubed. Next, we need to figure out the maximum possible volume. No, they say they want the maximum possible value of the total surface area of the cuboid. And so for finding the lowest possible volume, we had to use L min, W min, and H min. But for the maximum possible value of the surface area, we're going to use L max, W max, and H max. So we have to figure out what is L max. And L max just basically means what is the highest length we could use. Remember, each measurement is given correct to the nearest centimeter. So what is the highest length we could use? What is the highest width we could use, right? Right, what is the highest width we could use? And what is the highest, so length, width, and then height, right? So we have to figure what is L max, right? Width max, and H max, right? So once we figure what these three are, the highest length we could use, the highest width we could use, and the highest height we could use, then we're gonna use those values to figure what is the total surface area, the maximum possible value of the total surface area. And so let's erase all of this. And so what do we have? Well, we have that the L max is going to be the length is going, remember the length here is 5 centimeters, but we want the highest length that we can get. And we have to add 0.5 centimeters. So we have 5 centimeters plus 0.5 centimeters, and that gives us 5.5 centimeters. And then we want the width max, and the width max is equal to 3 centimeters. This is the width, but we have to add 0.5. And so that's going to be 3 centimeters plus 0.5 centimeters, and that gives us 3.5. And then we have H max, which is the height max. That's going to be 7 centimeters plus 0.5 centimeters, which is equal to 7.5 centimeters. So now to find the highest possible value that we could use for the length, width, and height, we had to, in each case, add 0.5 to each of the values that we are given. In order to find the L min, or the lowest width we could use, the lowest length we could use, the lowest height we could use, we had to subtract by 0.5. So you either could subtract by 0.5 or you're going to add by 0.5. But it depends on whether you're trying to find the L max or the L min, right? So what is the total surface area of a cuboid? It's given by this formula. It's going to be equal to 2 times the length times width plus the width times height plus the length times height. Now, this is a useful formula, but we're not going to be using the length, the width, and the height. We're just going to be using the L max, W max, H max, all right? So we're not going to be using these figures. We're going to be using L max, W max, and H max, and that's because we want to figure out the maximum possible value of the total surface area of the cuboid. So the maximum possible value of the total surface area of the cuboid is going to be 2 times, open bracket, L max times W max plus W max plus, 2 times L max times W max plus W max times H max plus L max times H max. I hope I said that right. Let me say it again. 2 multiplied by L max times W max plus W max times H max plus L max times H max. Okay, now we know what is the formula. Now we just have to substitute and solve. The L max times the W max is going to be equal to 5.5 centimeters multiplied by 3.5 centimeters. The W max multiplied by the H max is equal to 3.5 centimeters multiplied by 7.5 centimeters. And the L max times the H max is going to be equal to 5.5 centimeters multiplied by 7.5 centimeters. And so what we have to do is we multiply these two. When we multiply these two, we get 19.25. When we multiply these two, we get 26.25. And when we multiply these two, we get 41.25. And so we add them. When we add them, we get 86.75 centimeters squared multiplied by 2. And when you multiply, you get what? 173.50 centimeters squared. So we have 2 times 86.75, and 2 times 86.75 is 173.50 centimeters squared. And so that means that the maximum possible value of the total surface area of the cuboid is equal to 173.50 centimeters squared.